Hello world, Wave Time here, bringing to you a tutorial on the Mobile Quarry MK. Due to popular demand and the incoming of Dire Wolf's 20s Horde of the Apocalypse, I have decided that, due to popular demand, that I should do a quarry on the very popular Mobile Quarry, a tutorial on it, not a quarry on it, because that would be very counterproductive. So, what I'm going to do is start off a bit and try to go step by step through the processes. So you know what's coming. First part's going to be the engine. Second part is going to be how to add the quarry head to the engine. And the third part is the coding of the whole contraption. You do not have to watch the entire video, so keep that in mind while you are commenting. Thank you very much for your patience. Now, the very first thing that you're going to want to do with your mobile quarry is to get the main directions of said quarry. It will take a bit of getting used to of the directions, but it'll be simple. First thing that you'll want to do is place down some of the scaffolding, meaning the frames, in a pattern similar to this. Just place it out and you're good. You shouldn't worry about the covers as of yet, since that would overcomplicate things and you do not want things overcomplicated, especially at this point. Once you have the base done, you should start putting down the directional motors. What this is right now is a 4-way caterpillar drive, and as such, you have to make it go 4 ways. What this does is, here's an engine. It takes an engine that goes here and pulls it this direction. Then this engine will, when it receives a redstone signal from a NOT gate here, pull it in the other direction by attaching to this frame and moving it over here. So, putting it here, we face it in the correct direction, making sure not to get it in the wrong way, and by having this arm pointing this direction, you know that it'll spin and go in this direction and pull the entire frame structure with it. So, make it in every single direction as such. Now that you got the main 4 directions, you'll want to put some panels over here. These panels will allow the NOT gate to stick to the structure so that you can move a bit when you are moving. Then you'll want to get some battery boxes and to put them on top of the system. This will maintain power while it is moving. Then you'll want to put some frames around here so that the batteries can maintain power. So, without putting any of the major wiring down on this structure, you can see that it already has 4 of the main directions, while sitting in a 5x5x3 cube, but it can't receive power yet. It will need to add a power module to the top of this, though that will come after. We will have to focus on getting the other directions down also. By the way, if anyone's watched my episode for it, it seems like this might be a mirror image of my structure, though I'm going to have to figure that out while I'm working. And just a quick FYI, it's probably a very good idea to place the wires down where you'll have your main directions. These should be the main simple wires first, the white, orange, magenta, and light blue. To keep it simple, I'll have the white and orange opposite of each other, and same with the light blue and the magenta. You can put covers here also because as it stands right now, when this receives power, this will no longer transmit any energy, which is bad. But to see how things are progressing as we are building it, we can leave that empty. To give ourselves a little more room, we add another layer to the design. Now we'll get one of the directions. This should be a very simple one. First direction, I believe, will be in the downwards direction. You'll want to make sure that the one that's going to receive a signal is here, and the one that is going to do the movement is facing the contraption, facing the exact same way. You're going to need to take a few minor adjustments while you are building this system, so keep that in mind. No system is completely perfect at the beginning. In fact, it's probably best if they're not perfect. In fact, I do see one issue with the system right now. It should go in the other direction to get things a bit more lax, I'd say. So get it here, this will pull it up, and if I can get it, it will face the other direction and pull up. Simple, really. This will pull it up, this will push it up. All that you'll need to do for that is just add another NOT gate here and some wiring leading to this structure. It's best to keep some constraints in mind, like not being completely wishy-washy with the design as you are going at it, though keep it in mind that it is not necessarily that you will get things perfect the very first time. For instance, when I designed mine originally, it took many attempts to do what I managed to do. So keep that in mind. And also, covers are your best friend. Obviously, since we have the upwards direction right now, you might as well get the downwards direction. You'll have to have it facing downwards. You guessed it, Jimmy. And be able to receive some sort of signal while still being compact. Now the compactness is going to take a bit of an effort to get because you'll need to figure out where all the blasted wiring goes. For instance, if I remove this frame here, I can put a wire here. But this frame does need to stay here. So if we put a bundled cable here later, we can attach the wire that goes here and the wire that goes here together, while maintaining attachedness with the remainder of the structure. So when we place this down and orient them, they should give us the desired vocations, and adding a NOT gate will complete that system. Now it is important when you get to this point to test your system. How I usually test it is to grab a few batteries and to fill the battery boxes up. If you're using NEI, the battery that you want to use is the second one that appears. The first one is completely empty, so grabbing that and putting it in the slot is wasteful. Very wasteful. And before I forget, it's probably a very good idea to make some connections for all of your other directions. For instance, as you see, the up and down directions are not directly connected to any sort of system whatsoever right now. So you'll need to rectify that. To do that, you can just pull it for that. Now this will be connected and gather energy from this engine, though it'll be a bit slow. And this one, you just need a single connection. Now wherever this moves, it should remain connected. Now, as you see, without all of the fancy wiring, this is fitting a 4 by 5 by 5 footprint. You can add solar panels here, but as of now that is not a very good idea because we'll want to add a few more solar panels than this. You'll see why when we get there. Now that it seems like it's all hunky-dory, everything can move, grab yourself a few redstone torches because you'll want to do some temporary connections. This one, as you see, is going to be in the upwards direction. Yes, it is upwards, so that's good. Upwards, testing upwards. As you can see, it doesn't seem to work. For some reason, there is, well, this engine doesn't seem to want to be pulled, meaning that there's an unnecessary connection somewhere. You'll want to make sure that it's working, so you see that the frame motor is working, so it needs some sort of encouragement to move. This encouragement can come in the form of some covers. Now you'll have to experiment whether covers are the best idea or if there's another thing. But as you see, it moves now. If this is a temporary connection and it can move with the rest of the structure, it should be good. So let's try this direction. That direction works. I should remember which color goes where. It would be a very good idea way. Now taking the light blue, testing that direction. Light blue works. Testing the white direction. We will see that, if we fall, white direction also works. And the magenta one works as well. And finally, we're going to have to test this one. So we're going to have to probably put another frame here to temporarily test it. Actually, we can just put one of these torches here. And as you see, there seems to be some sort of issue with this. What I am thinking right away is that maybe there's a misorientation issue or it needs some covers here. I am guessing the latter, so let me fix that right quickly. And when we finally test it again, it's working. Now we have all systems a go. Every single part of this system is working. So what you should do is give yourself a bit more space and raise up the engines. And there are a few specification issues that should be addressed. As it stands now, there's no way for it to get power. But you'll also need to wire up every single part so that it can be connected, while making sure that one of these batteries is exposed to the rest of the system. So you should take some bundled cables and get hopping on that. Bundled cable here, because actually here might be a good idea. So put one of those here. To connect this, it will need to connect to here also. So we can either put one of those here or here. And if we leave this exposed, it should be good. Okay, with a bit of tinkering, you can see that I managed to wire everything into a single cable. It does look quite messy, but I will look at each part in turn. Now, as you see, it all comes from here, goes around, back over here, down to meet the blue wire. Over here, these are jacketed bundle cables. Here's the orange. Up here is something that will hold this wire. There will be a frame on top of here instead, which then goes to the remaining wires, as you see. Now I brought a wire down here also because we will be using this wire to connect to the main, let's see, I think it's called a computer. It might be a bit necessary to get everything here. Now also you'll want to get a bit of the framing work for the solar cells. So let's get some of that done. We're going to probably need to put, a panel right here so that we can move that, but it shouldn't be too much of a bother. So this build will become a lot better when we finally are able to put jacketed wires inside of frames. Now removing this temporarily to put that there so that we can go around, put a frame where that was. I've been framed! And then put those down again. And we probably don't even need that. Yes, we do. Durr. So, frame the top of this. And see what area is left to us. We see that we got quite a bit of an area as it stands right now. So, place this down here. And make way for a jacketed cable. Let's see. With how this is gonna be right now, we have 19 solar panels that this system can connect to. Now, there are good things and bad things with that design. If it is 19 solar panels, it might be enough to run it 24/7, assuming that it has enough battery life. Now the problem is that it might not be enough. So if it's not enough, we're going to have to find some way to adjust that. So in the meantime, let's get some blue alloy wires here. Actually, let's change that so that we can get... Now let's get that blue alloy wires here, and we'll also need some solar panels here. Put that down again. Put there. Get a wire or two, maybe 3, to have that connected. And then connect all of the solar panels to the system. I'm not sure on the calculations. Depending on the size of this quarry, that should be enough. Now, whether everything is still moving after this, we're going to have to find out. So we should probably do that right now. The main problem I'm going to see is this one, where it might not get its power that it needs. So let's put down a frame temporarily so we can test the power, and we see that it moves. Good. Now if one of the other directions moves, that means that the rest of the system can move. So by eliminating this and testing it, we see that it moves, and therefore it is A-OK, everything is connected, and we have a completely self-sufficient 6x5x5, what would this be? A dirigible, yes. Now as you see, I have a wire down here. I think I already stated that, so let's move onwards to the quarry head. The main thing that you should have for the quarry head is that it should be pretty much the exact same size as your quarry. So elevate it a bit so that you will have a good working area, and maybe build the stuff right under your quarry so that you have a good indication of where everything is. So we got one corner here, one corner here, one corner here, and one corner here. Now my design features 10 block breakers. Of course, they're all facing downwards, which we'll have to rectify. And we got the block breakers. Should be faced like that and orientate. Now the block breakers are going to need to be connected to a few things. They will need to be connected to supporting frames, and they will need to be connected to redstone tubes. Redstone tubes here. The reason for the frames is simple, really. They kind of need to be connected so that they can move with the rest of the structure. Tubes, on the other hand, you can also see for yourself. Okay, now we have frames attached to these block breakers, and we got redstone tubes. Now the convention is usually putting more frames here to attach the redstone tubes, but I kind of buck that trend. I put frames on top of here and here to maintain compactness. Setting day for you guys. Whereas I put the redstone tubes here for future use. Now also I'm going to have to edit this slightly so that I can maintain connections everywhere, which isn't a problem. So if I move this slightly, I can put on top one of these and one of these, as well as one of these, so that when I move this down, I'll know that this will be where everything is connecting. I might have to move the tubes to say that's what I'm doing, like so. But it's a simple matter. Remember, you have to be flexible when doing this system. If you're not, you will hit many roadbeds. Now, to put a computer in here, you'll have to remember that the central processing unit has to be on a solid block. That is a must. If it's not on a solid block, the RAM has to be on a solid block. If it's not on a solid block, it cannot move. So, getting all of that computer stuff. Now you see that the central processing unit is here, whereas this 8K RAM module is on top of the solid block, as well as the backplane. Now you gotta figure out where you're going to want your I/O expander. I'll probably put it here temporarily, so that it's connected directly to the central processing unit. And I'll put a disk drive maybe here, and a monitor maybe here. So everything's connected. You'll probably have to reach in to turn on your system when you are ready, though that is going to be up to you when that should be. So put a few more panels on this system and get the wiring connected. We have a jacketed cable here so that we can, when we lower the system, it will go on top of the system and connect right directly with that. And there's also a small thing that we're going to need. We're going to need some sort of chest. Now, I am a user of equivalent exchange, so I am going to use an alchemy chest, though you can either do two things. You can have like an ender chest here, or you can have a regular chest and a chest room. It is possible, but I want to add a filter to this device so that I'll be able to pull items from it when the need arises. So say I get to a central docking system, and I see that the frame will line up to it. Now there's also going to need to be some way to connect this redstone to here, so we'll need a jacketed cable. Connecting the jacketed cable here with a red alloy, as well as a pink wire, will connect the system when we put down one extra bundled cable. Now there's going to be one thing that we might want to add depending on how we want things to go. What I'm talking about is a kill switch. A kill switch is something we'll want to program in if we want to stop the quarry if there's something wrong. Something wrong meaning like there's a jam in the system or something similar to that. So you're going to have to put a few things down, but maintaining room to access the CPU when we get to that point. Say we put that there, we'll put a wire here of some sort, and then a single cover to cover up this place right here, where our kill switch, which will be a toggle latch, will go. If we get our toggle latch as well as a wire of the gray kind, we can put the gray wire down and the toggle latch down. Orient it to your liking, like so. This toggle latch will become more apparent when you are actually doing the coding. Now, making sure that everything is connected, you connect this part to your system. And might as well boot up the system by going to your CPU, starting it, and your system should be booted up. Now, looking at it, assuming no other changes, we got 3, 4, 5, 6, 7, 8, 9 layers, and this should stay powered constantly. I'll lower this down and see if there are any glitches. If not, we can move on to the programming. If there are, I'll do a few tweaks and mention those tweaks. Okay, obviously there was an issue. It was something so flagrantly obvious that I didn't see it right away. This wire wasn't connected. So all I needed to do was, now it's working. As you can see, it's working. So I'll reinstall all of that and then continue on with the demonstration. Before you start, make sure you put a cover on absolutely every place that you can. If you do not, when water comes into the system, it might stay connected, meaning that it won't move anywhere. Now, some of the places can be exempted, for instance, where these engines move out because they can naturally just break off the water. And water can move quite fluidly. So now let's get into the coding aspect of our system. I thought I was in Mine OS version 1.1. I forgot to update Red Power, but no matter, the code that I am going to show you does work in the Mine OS version 1.1. I have to remember before continuing my Let's Play to upgrade that, because if I don't, it could be very troublesome when I start. So there are a few things that we're going to want to do. We're going to want to be able to raise the system up to a certain level, lower the system to a certain level, and move in any different direction to any single level. To do that, we're going to have to remember each of our current positions. So we have to do variables for that. This variable will be for our current x, then for our current y, then for our current z. Getting a little ahead of myself. There we go. Now we have variables that will remember the position of the quarry. To remember that, let's type in calibrate as a new word, and we'll assume that we're reading directly from our F3 thing, so it'll be the X, Y, Z that'll be on the stack, and because of how the stack works, we have to transcribe the current Z first, then the current Y, then the current X, and end it. So when we go to calibrate it, we now calibrate the system. There, simple. Now, what will these be used for? These will be used to help with our movement and navigation system. I'm going to do a bit of flying so I realize which engine does what. So the white engine will do the positive X. That means the orange will be negative X. Magenta is in the negative Z, light blue is in the positive Z, and we see that yellow is up, whereas lime is hidden and down. Hoping that wire connects. Hope it's not connected. That could be a problem. Let me rectify that. There, all better. Now let's get to the coding. One of our directions that we'll be doing is the positive X. Positive X uses the white wire to do the movements. I'm going to add a variable called delay 1. The reason I want to do this is so that I can tweak the delay while I am doing the setup. So delay 1, let's put an initial value of 14. And transcribe it like that. Good. So now when we go to write our positive X direction movement, we can then use the white wire, which is 1, and set it. Do a delay of 8 ticks, reset it, and then do a delay of 1 at ticks. Now, to get the direction and to tell the calibration where we are right now, we do something similar. Simple and effective. We just add 1 to current X. So we take current X, put it on the top of the stack, add 1 to it, and put it back in its place. So when we move it, plus X, it will move. Let's do that. Now it's going away from me. Similarly, we do it with every other direction, and it will be the exact same code, but changing the one IOX set to different numbers, and changing the current.x to current.y or current.z, and the plus to minus depending on the direction. And as you see, everything is good. So let's try a slight interesting thing. Do a few movement tests by doing every single one. So initiate that. 1 movement, 2 movement, 3 movement, 4 movement, 5 movement, 6 movement. Okay, good. Turn the rain off and continue on. Now we'll want to write 2 programs that will need a lot. The goTo command and the raiseTo command. goTo will take an X and Z coordinate and take you to that location. So obviously the first number that will be on the stack is the Z coordinate. So you need to compare that to your current Z location by doing that. Then duplicate the number for the following processes, but I forgot we are forgetting one special word that I will need, inverse. Inverse takes a flag, so whether it's true, it'll turn it to false, and vice versa. There we go. Now that will return a flag when I use it, and it is crucial in my goTo command. So, like I said before, we'll duplicate it twice 0 equals, compare it to 0, and inverse it. If it's 0, meaning if they are the exact same location, it won't do anything. But if it's greater than 0, we'll do a few loops. We'll do the loops in the positive z direction, and then loop that a bit. Else, we do them in the negative z direction, but we have to remember to multiply that number, because if we don't, it will do infinite loops, which is a bad thing. Not strictly infinite, but you will be tired of waiting all that time. So close all of those, drop all of the excess numbers if it happens to get that to that point. That should be a then. And then we do the exact same thing for the current x direction. Similarly, when we do a raiseTo command, instead of using an x or z coordinate, it will use a y coordinate. So all you have to do is pretty much copy half of that text and change everything to y. By the way, it's always a good idea to save often, because you never know what will happen to your device. Blank. Okay, so the goTo command should work. We'll assume that it works, but it pretty much works in the fact that it will go in the z direction and then the x direction to the desired location. I'll assume that you've watched my Quarry Machine project, so you can look at it there if you have any questions about it. Now, what we'll want to do is make a word that will tell us whether the kill switch is flipped. It'll be called kill, and it will return a flag, positive, meaning true, if it is actually true. So 128 is our gray wire, and then we have to take IOX at, so check what's in it, and compare it to each other. If it happens to be in there, we can compare it to 128 and equal to it. This will return a flag whether it's true. So let's test that. Type in kill and check what's on the top of the stack. We see it's 0, so it's false. Do it again. It's true. Good. So that's working. Now we'll have to do a few other variables to get our query done. We'll have a variable x, variable y. These are pretty much an x and y coordinate system on a grid. So say this is the corner of the grid, this will be the x direction, and this will be the y direction. It's for simplicity's sake because I don't want to do too many x's, z's, etc., etc., etc. We'll also get a variable x and a variable z with a variable height and a variable h. So the capital X, capital Y, and the H represents the stuff that you're going to be plugging in for your dimensions. That'll mean that when you plug in like a 20 by 20 by 20 and type in dimensions, when I get that word in, it'll prescribe it all into those three variables, and it will be interpreted when you run the program. Whereas the little x, the z, and the height say the position of where the quarry is at that moment. So it will basically say the position on the grid. So x will be here and z will be here. A bit convoluted, but you'll figure it out while I am typing a bit. We might as well get the dimensions word in it while we are thinking about it. So dimensions. It'll be x, z, then y. Y being the height. So we'll prescribe height, the h, and then we'll have to do an operation on the z operation. Let's see. We'll need to do a 5 modulus. So divided by 5. Then we'll need to put the division inside the y, then drop the remainder. Whereas for the x, we'll do a simple subtraction of 5. Let's make it 4. I believe that is an alteration I needed to do earlier. Take that and put it inside x. So if we type 20 by 20 by 20, it should record it inside and shouldn't leave an empty stack. Good. Now time for the rest of the code for the quarry. We already have the dimensions set, so getting that out of the way, we can do our go left and go right commands. Basically, go right will, when looking at it like this, make the quarry go right. Then it'll go to a certain point, stop, then it'll go forward, then it'll go left, forward, right, forward, left, forward, down. Eventually, then it will go backwards and repeat the process. To make this smart, it's going to have to continually modify where it is at that point. So our x, our little x, is the thing that we're going to modify to say our position. So this position right now, it's at x equals 0 and z equals 1. So let's do our go right command. Our go right command is going to use 2 because 2 is our orange wire and it is going to go in the negative x direction. So 2 IOX set 4 ticks, 2 IOX reset, and then we're going to do 64 IOX set 4 ticks, 64. Do a delay 2, a different type of delay. And there we go. Oh, and of course I need to do all the way capitals. Stupid me. This is one of those languages where it's probably best to write with cap locks. English is not one of those languages, so please don't respond with cap locks messages. So, then we're going to add 1 to x and then put it back into the system. And also, since we're moving in the negative x direction, we're going to have to update that counter so that it's back and make sure that it knows where it is for future use. Now that we got our go right command, go left is going to be exactly the same, but pretty much the positives turn to negatives and vice versa, and instead of a 2 IOX set, it's going to be a 1. Also, I'm going to add a break word instead of the 64 IOX set blah blah blah. So I'll do that. And there we go. If we put 0 as what it currently is for the x, when we type go right, it should go to our right. And go left, we'll bring it to our left. There, so those are working. Now we'll also want to do a go forward. Go forward is going to assume that 5 blocks in this direction is 1 cell. So it'll go over 1 cell by moving 5 times, and then adding 1 to the lowercase z variable, like so. we'll need to do a do loop of 5 times. And this do loop will use number 8 because that is the light blue wire. And then reset that. Since it's going in the positive x direction each time, Z, we should add 1 to each time of that. And close the loop. So when it goes, it should, each time it moves, add 1 to its current Z position to maintain track, and then finally add 1 to the Z variable and close that word. And we'll do the exact same thing, but with go backward. We'll reset Z to equal 1 and then test go forward. If it works, good. If not, we'll try again. So there's 1 movement, 2 movement, 3 movement. There seems to be an issue with this. I'll find that and see what's the problem. Oh, I forgot to add a delay after break. I'll just quickly re-edit the words so that there's a delay between each one, and that should rectify the problem. Now, if we actually test go forward after the alteration, 2 movements, 3 movements, 4 movements, 5 movements, and that's good. Same with the go backward command. And the final thing that we're going to need to do to get the movements that we need is add a go down command so that it's able to go down for the quarry. There we go. Now let's raise the roof back up again and reset all of the values that we were currently editing. So 0, 1, and 0. Okay, now this is where all of the intelligence of the machine comes into play, with 4 of the main comments: left.f, right.f, right.b, and left.b. Let's start with right.f. All caps will go. Right.f is going to start with a begin while repeat loop, which will continue repeating until a certain condition is met. So for instance, if either the kill switch is flipped or our x coordinate meets the big X boundary, or an inverse is pretty much the same as a NOR gate. If either of those conditions turn true, it'll exit out of the loop. And by doing while, it will cement that. So while this thing is true, so while neither of them is on, it will continue going right and repeat. When it finally gets to that point when one of the conditions is true, it will check whether kill is true. If kill is false, it will allow to check whether it's allowed to go forward or not. So we'll compare the Z boundary with the Y boundary, the Z position with the Y boundary, I should say. If they're equal, we add 1 to the Z. If they are not equal, it will continue on. It'll test it anyways, but think of it, if this part is not equal, it will check whether the Z is less than. While the Z is less than that, it will go forward. And to close it all up, you do then, done. Okay, so say we have a 10 by 10 by 2 quarry. If I check the x value, you'll see that it is a 4, I believe. 6. 6 works. I might have to edit that, but we'll see how that goes. So if we do write.f, it should go a number of times. 1, 2, 3, 4. And 2 more times. So I'll slightly edit my dimensions code, and then it'll go forward again, which is what we wanted. Now I'll add the left.f thing, and it's pretty much exactly the same, but with one key difference. Instead of it comparing with the far x boundary, it'll compare with the 0 boundary, which is over here. So it will compare the x with 0. If it is equal, it will come out of the loop, and it'll go left while that is going. And then the final 3 lines are exactly the same as write.f. So this is the point. Since it's a 10 by 10 quarry, it will not go any further in this direction. It'll go 6 or 7 times in that direction though, so if we do left.f, it will go over the amount of times, but you'll notice it should not go forward after this. So when my cursor lines up with the monitor, it does not go forward since it has reached as far as it can. So let's go backwards a few times. Okay, ignore that first left.b that I have and only look at the 2 words there. So I'll give you 3 seconds before I continue on. Time's up. Okay, going onwards, now we should do a full forward command. Basically, it's going to continually checking whether it has finished going far enough in this direction to be allowed. So, and after that, it will go downwards if the kill switch isn't the thing that ended it. So, we'll add the word full forward. It will begin like any other, but compare the z with the y boundary and check whether it's greater. And do a nor and while. Then, within the while, it'll take z and do a modulus. Basically, this modulus, there's 2 things with the modulus. You get the division and the remainder. What we want is only the remainder, so we drop the division. We check if it's 0. If the remainder is 0, we're going to go left. If it's not 0, the only other option is 1 in this case, it'll go right. And repeat. And then finally, we'll do the kill line. The kill, it'll check if it is false, yet again. If it is false, we will go down. And I think I will do a slight edit to my dimensions word right now. So 1 moment. Okay, I finished editing the dimensions word. So it should give the correct dimensions. So now I will try a full backward word, assuming I spell it right. So it's pretty much going to be the exact same, but instead it will then compare the z with 2 and check if it's less. But otherwise, instead of changing the f's to b's, it does the exact same thing. Okay, now let's test this out with a simple 10 by 10 by 10 quarry. So I'll check my numbers. See, it should be 4. If it's 4, then great. Okay, so let's do and check our other numbers, because if these are wrong, yep, like that, it will mess up our quarry even more. even more. That sounds like it has a plague. And I forgot my main rule that I should do. Okay, so let's do full forward and test if it works. Obviously, we're not quarrying anything. So it went down 4 times. Now it's going to go forward. Maintaining power quite lovely. Now it's going to go over 4 times. Then it'll break once, then go downwards. Good. Now if we go full backward, it will do the exact same thing, but pretty much retrace its steps. Failed at typing again. 3rd time's the charm. So now what the system does, it starts at a height of 0, and then whenever it goes down 1, it'll raise that height counter by 1. So we take that into account, so when you take the modulus of it with respect to 2 and drop to only take the remainder and compare it to 0, you'll know that it'll start with full forward, then it'll go full backwards, and then continue on indefinitum. So if full forward, else it'll go full backward. Then, and it'll repeat it. That was a quick compilation. Finally, it will take the current x and dump it into the previous x, as well as it does it for the other directions. Sorry for my loud keyboard. And finally, there. But we'll want a way to start the system so that it'll reset those numbers if we want to do another query entirely. So for that, we'll have our word start. We'll set the x to 0. We'll set the z to 1. And we'll set the height to 0. And then we'll use the resume word because it's smart enough to know that it'll resume at its initial position. And there, so that should be perfect. And the kill switch, if we test with start or resume, let's test with resume, the kill switch works perfectly. Okay, so let's start this query with a simple thing. Let's go down, what is it? 1, 2, 3, 4. Let's go down by 4. And then make a query that's 10 by 10 by 2 to test if everything is working. Kill switch off, good. So then, let's page it, save it, and then start it. And it's working right away. So then it'll go over. Now obviously you don't want to do a query that's this small since there's no point. It'll go over 1. Then it'll go over here. And then it'll go down and continue. This power might be enough, but if it's not enough, all you will need to do is just raise the roof by, instead of this layer being here, you just put it up 1 and you'll have up to 23 solar panels, which should definitely be enough. And it'll go down to say, hey, I'm done, everything is perfect. I've got a bit of stuff in my alchemical chest, but I want to make it a little more clean and then do one of my friend's items, the gem of eternal density. Of course, there's not enough stuff to densify it, but whatever. Well, I guess that's all for this tutorial on my quarry machine. If you like what you see, don't forget to rate, comment, and subscribe. I'll be starting my new Let's Plays season, which is called EE Power, if anyone is interested in viewing it. It will be out on Monday, so I must say, shameless self-promoting. Wave time, signing off. Have a wonderful day.